This lecture is going to be over the inverse square problems. This is a concept that you will definitely need to be able to master as you go forward here in physics. Now, why do we need this? What's the importance of it? What you're going to find here is that radiation is going to obey the inverse square law. What that means is, let's say you have a source of radiation here. Let's say you're standing here. You've got somebody else who's standing here, and you got somebody else who's standing here. This person is a set distance away. This person's twice that distance away. This person is 3 times the distance away. The fact that you are set distances away from each other, once, twice, 3 times a particular amount, you're not zapped with half the radiation here that you are here. You're actually zapped with about 1/4. Here, you're zapped with about 1/9 of what you were here. What this means is that you are obeying the inverse square law. The dose is going to drop off with the square of the distance as it changes. So that's something you're definitely going to have to take into consideration as you're going along and you're working these problems. So let's take a look here at number 1. So increasing the distance from 80 cm to 90 cm causes the dose rate to change by what? How do we solve this particular problem? Well, here's what we're going to do. We have our dose rate going from 80 cm to 90 cm. This is going to be how the dose rate changes. So in other words, you've got a dose rate that is here at 80 cm, and then you've got another one here that's running at 90 cm. So this is how this is going to change. So this is basically the same thing as saying 8/9 squared. And if you multiply that out, which I don't have my calculator running here. You can see that this ends up being something close to 7901. Okay. Now let's take a look here at problem 2. The intensity of the beam at a distance of 50 cm from the source is 90 Roentgen per minute. What is the intensity at a distance of 100 from the source? Well, let's take a look here. Again, this is going to change according to the inverse square law. You've got 50 cm. 100 cm. So this is the kind of ratio you're going to have to work with. Now remember that our dose rate here, or the intensity, is going to end up being the intensity at 50 as opposed to the intensity at 100. This is what we're looking for. And we know that the, oops, I think I've got this backwards. Sorry, hang on just a second. So if we change this around, the intensity at 100 cm is going to end up being the intensity of 50 cm times 50 over 100. So this ends up being 90 Roentgen per minute times what ends up being, and let me go here, clear out everything. Whoops. 50 divided by 100, square that, so you got 0.25. I may have to try to squeeze this in here and it may look terrible. So 90 times 0.25. Let me see if I can write that a little bit better. Matter of fact, I know how to do this. Let's see. So there you go. All right. Let's move on to number 3. The dose was calculated to be 180 centigrade treated at 100 SSD. So what would the new dose be if the patient were actually treated at 80 SSD? So in this particular case, the dose will end up being higher. And that is because we are treating this at a shorter distance than what we were before. So the dose at 80 cm divided by the dose treated at 100 is going to end up being higher. That ratio should end up being greater than 1. So now we don't know what this is. We do know that the dose at 100 equals this. So then we should end up with 100 cm divided by 80. What does this end up equaling? Let's see. $281.25. Tracker? Yep, sure am. Okay. What did we say it was? 281.25. So that's the answer there to number 3. Clear that out. Let's take a look at number 4 here. If the dose were calculated to be 250 centigrade at 80, what would the new dose be if the patient were actually treated at 95? For some reason, you scooted the patient 15 cm away from the accelerator. So let's see what's going on with that. So we should end up, let's see, the dose. There we go. Dose at 80 centigrade divided by the dose at 95 centigrade. So that would be 250 centigrade here divided by the dose at 95. And that would end up equaling 95 cm divided by 80 cm squared. So the dose at 95 would end up equaling 250 centigrade times, rearranging this equation would be the reciprocal there, 80 divided by 95 squared. So dose at 95 is going to end up equaling what? Well, $117.28. Wait, did I say 117? 177.29. So that'll be the answer there to number 4. All right, let's move on. Let's take a look here at number 5. The SSD is increased from 50 to 70 for therapy unit. The absorbed dose is 90 centigrade at an SSD of 50. What will the absorbed dose be at 70? So we're going from 50 to 70, so we should end up with a smaller dose than what we've got here. The question is how much. So let's take a look here. Got the annotation going. All right. So the dose at 50 cm divided by the dose at 70 cm is going to end up being equal to, let's see, so you should have a higher dose here than what you do here. So the absorbed dose, let's see, should end up being 90. Whoops, sorry. Not doing this right. Forgive me for that. So the dose here should end up being 70 divided by 50 squared. And what does that turn out to be? Well, we know that the dose at 50 cm is going to be equal to 90. That means we have 90 divided by the dose at 70 cm is equal to 70 divided by 50. This is the same thing as saying the dose at 70 cm is, let's see, if I take this and put it over here, take this, put it over there, is going to be 90 centigrade times this. So let's see, let's do some calculating work here. So we got that. Turn around, square it, multiply that by 90. And that should be 45.92. Now, is that in fact what we've got here? 46. There we go. That's the answer for number 5. Let's take a look at the answer here for number 6. What dose was given to a point that was calculated to receive 300 centigrade at 100 cm SSD, but was actually treated at 94? In other words, they scooted the patient in 6 cm from where it should have been. So let's see. The dose at 100. Okay, let's try this again. Okay, so the dose at 100 is going to be less than what we see here. So it's going to be 94 divided by 100. And we're looking for what was actually delivered at 94. So that's going to end up being the dose delivered at 100 multiplied by 100 divided by 94 squared. So that's going to be 300 multiplied by that ratio. $339.52. What did I say it was again? 339.52. Okay, so that's the answer there to number 6. Let's take a look at number 7. If a patient was supposed to receive 200 centigrade at a planned distance of 100, but pardon me, 150 centigrade was actually delivered, at what distance was the patient actually treated? In other words, they were supposed to get this. What they actually got was this. So they weren't treated here. The question is, at what SSD were they treated? Now, if they ended up receiving less dose than what they were supposed to, this SSD they were treated at is going to be much greater than this. Question is, what is it? So we know that the dose delivered at 100 divided by the dose delivered at something, and we're not exactly sure what that is. We know that it was, sorry, let's take that out. We know that it's some value, x divided by 100. Again, we don't know what x is. What we do know is that at 100, the dose should have been 200. We also know here that should have been 150 centigrade is equal to x squared over 100 squared. Remember, that's going to be 100 cm. This is the same thing as saying x is equal to 200 centigrade divided by 150 centigrade multiplied by 100 cubic centimeters. So let's take a look here and let's try to figure out what that is. So if we go here, got 200 divided by 150, okay, times 100 times 100. So 13,333.33. We take the square root. To 115.47. Is it the same as we've got here? Yep, sure is. Okay. Let's go ahead and clear all this out. And then finally here, at 30 cm SSD, a 1-minute treatment delivers 90 centigrade to the skin. If the treatment is changed to 1/2 a minute at 15 cm SSD, what's the dose going to end up being? Well, we know here that if the time ended up being the same, that we could use the same type of relationships that we have up to this point, meaning we could take the dose delivered at 30 cm divided by the dose delivered at 15 cm is going to be the same as 15 cm divided by 30 cm squared. We are interested in the dose delivered at 15 cm. So again, this is going to be the same as the dose at 30 cm times 30 divided by 15 squared. We know that this value is going to be 90. This is going to end up being 4. So it's 360 centigrade. But are we done? No, we are not. Because this dose, actually, this dose right here for 30 cm was a 1-minute treatment. So in other words, that 90 centigrade was delivered over 1 minute. The treatment time got changed to 1/2 a minute. So what we need to do is take that and divide it by 2. And so that's our answer. So I hope you got a little bit of clarification here on using the inverse square law.